Good morning. In this lecture, we're going to continue to generalize our process. So first we looked at the instantaneous rate of change, aka the instantaneous velocity at a point. So we were specifically talking about distance and time. We then talked about the instantaneous rate of change at a point for any function. Well, both those guys were point-wise, so we did them at specific points. If we'd like to generalize or abstract that, what we're going to do is instead of thinking of a single point, we're going to use x to represent that point so that we can actually develop an entire function which spits out the slopes for us, or the instantaneous rates of change. So that's what we're going to talk about today. So in particular, we're going to study f prime of x. And f prime of x is really the same formula as f prime of a, except we have an x, where x is representing any point, instead of a, which represented a single point. So we're going to take our average rate of change of our f of x values. So we're going to go from f of x to f of x plus h in the y sense. And in the x sense, we're going to go from x to x plus h, so that would be the change in the x. We'll then take the limit as h approaches 0. So once again, I can really tidy up the bottom and just write it as h. The reason I'm writing it here, again, is to remind us that that is a change in x value. So you might be saying to yourself, well, this looks exactly the same as what we did before. I'm just using the letter x instead of a. That's right, but the subtlety here is that this x is representing any possible value. So what's the power of this? What's the whole point of this? Well, let's do an example to see why this is useful. Let's start with the function f of x equals x squared. In the old days, if I said, hey, can you find the derivative of this guy at 6, 7, 10, 12, you'd have to compute a whole bunch of limits. You'd have to compute a limit for each one of them. Watch what happens when we compute f prime of x first and then ask these questions. So f prime of x in this case is the limit as h goes to 0. F of x plus h is x plus h quantity squared minus f of x all over h. So I'm going to give you a minute, pause the video, see if you can actually work this out. Well, hopefully you said that this is the same thing as the limit as h goes to 0. Foiling this guy out, I get x squared plus 2xh plus h squared minus x squared all over h. The x's cancel, and I can then factor out an h on top. So I have the limit as h goes to 0, h times 2x plus h all over h. We know that h is not 0, so I can cancel these guys. As h gets close to 0, x could care less. It's not affected by h. So 2x plus h gets closer and closer to 2x. So this tells me that f prime of x is 2x. Now if I ask you, hey, what's the slope of this graph? What's the derivative of this guy when x equals 1? It's a piece of cake. Answer, 2. F prime of 1 is 2. Hey, what's f prime of negative 1? Easy, negative 2. Again, I computed the limit one time, and now I can just plug values in. F prime of 6, easy, 12, just 2 times 6. So that's the power of coming up with this abstract function. We only have to compute the limit once. I want to point something out at this point in time regarding the sign of the derivative and how it relates to the function. So this is f of x equals x squared. We all know what that looks like. And looking at the derivative function and looking at our graph, we might realize something. If x is bigger than 0, this guy here, 2x, is going to be positive. So if x is bigger than 0, our f prime of x is positive. And in that case, f of x is increasing. Right, look at the picture. If x is less than 0, if we look at our values here, f prime of x is going to be negative because 2 times the negative number is going to be negative. So f prime of x is less than 0. F of x decreases. And finally, if x equals 0, f prime of x is 0 as well. 2 times 0 is 0. And in this case, if you look at the slope here, we have a horizontal tangent line. And our function is neither increasing nor decreasing. But let me just say horizontal tangent line. All right, so I missed there we go, horizontal tangent line. For the purpose of this discussion, I'm actually most interested in these two guys. So question, is that always true? In other words, if f prime of x is bigger than 0, will f of x increase? Sure, because if f prime of x is bigger than 0, that means that the slopes of the lines, of those tangent lines, are positive. So our line is moving in this direction. In other words, our function is increasing. If the derivative is less than 0, the slopes are moving this way. But if the slopes are moving this way, then the original function must be decreasing. We need to pause and think about this. This is an amazing fact that we have just discovered. We have just discovered that the sign of the derivative is intimately related to whether the original function increases or decreases. In fact, if you just know the sign of the derivative, that can tell you exactly what's going on in the original function. It can tell you, oh yeah, increasing, decreasing, increasing. That should be pretty mind-blowing because f prime of x is just some algebraic thing we came up with in some sense. So let me box that result because it is something that we're going to be using throughout the quarter. So f prime of x bigger than 0. This tells us that f of x is increasing. F prime of x is less than 0. This tells us that f of x is decreasing. Okay, so let's actually do an example with that and introduce an idea which will also be used throughout the quarter. So let's say you're given a graph. Let's see, this is 0.5, it's -2. Okay, so you're given a graph, and this guy is f of x. And what I would like to do is I would like to sketch f prime of x. So you're welcome to give that a shot. Maybe explore that for a little bit. I have a definite technique that I like to employ, and pretty much everybody else likes to employ, but it might not be a bad idea to just start thinking about it. So pause the video, just think about it for a minute or two. All right, so hopefully, at the very least, you said to yourself, well, about what we just talked about, I need to figure out where this guy is increasing and decreasing, because that'll tell me about the sign of f prime of x. Okay, so that would be step one. So what technique do people use to do this? Well, the technique people use is something called a sign chart, and this is something you may have seen in a pre-calc class, maybe graphing polynomials or rational functions or something like that. So the sign chart is going to be the sign of f prime of x. And I would highly recommend labeling your sign chart because in a couple of lectures, we're going to be talking about the second derivative. It'll have its own sign chart. Things can get very confusing if you don't label it. So the things that I'm going to put on the sign chart are where this guy is positive, negative, and 0 are not defined. So by our previous discussion, this guy is going to be 0. Where? Pause the video, see if you can figure that out. Well, hopefully you said this guy's going to be 0 right over here. When I say this guy, I'm talking about f prime, because this guy has a horizontal tangent line there. This guy has a horizontal tangent line. In fact, it's got another one right over there. So here's another place where it's 0. Okay, so these are the places where our original function is 0 or not defined. Well, if it's neither of those two things, then it has to be positive or negative. F prime of x has to be positive or negative. So try to fill in the signs for f prime of x. Okay, hopefully you said f prime of x is going to be negative here because that's f of x is decreasing. F prime of x is positive here, and f prime of x is negative here. Once you have the signs of f prime of x, my recommendation is to ignore f of x. I see it time and time again. Students get sucked into what f of x is doing. Doesn't matter what f of x is doing. All I care about is I'm going to sketch a function that's negative, positive, negative. So one technique that I like to do is to do this process right below the sign chart. Again, I'm not looking up here, but I can just move right down here. This is now going to be my f prime of x picture. F prime of x was 0 here. F prime of x is 0 here. And then I just need to sketch a function that's negative. Then it's positive. Then it's negative. Sorry, then it's 0. Then it's negative. So this is the picture I drew. This is the first derivative graph. All right, to conclude this lecture, I want to talk about a couple of specific f prime of x's. We saw that when we started with f prime of x equals x squared, we got f of x equals 2x. So f of x equals x squared, we got f prime of x equals 2x. What if f of x equals mx plus b? What's f prime of x? Well, this one you can actually do without, you can get the answer without doing any work if you think about what this thing is. Well, hopefully you said this guy's a line, right? It has slope m, and it has slope m everywhere, so that's what the derivative is. So I just kind of thought that through, but I want to show you guys how I would do that if I use the formal definition of the derivative. So that's what that limit thing is. It's the definition of the derivative. So let me say by definition of the derivative, f prime of x is the limit as h goes to 0. So we need f of x plus h minus f of x over h. So here's the over h, here's the f of x. Give you a minute, pause the video, see if you can write out f of x plus h if f of x is mx plus b. Okay, hopefully you gave that a shot. We said, well, x plus h goes in for x. I'm going to stick it in right there. So it becomes m times x plus h minus, plus b. If you didn't quite get that, don't feel bad. That's tricky for students. Sometimes it's tough to remember the parentheses, et cetera, but you're just putting the x plus h in for x. Okay, so we have the limit as h goes to 0, mx plus mh plus b minus mx minus b all over h. Goodbye b's, goodbye mx's. H's cancel, As h goes to 0, m could care less, and we get out m as we thought we should. Okay, so I want to generalize this further. I'm not going to go through the full proof of this, but I'm interested in x to the n. So what we've done so far is, let's see, we know x squared. So the derivative of x we know, because that's just 1x plus 0. It's just a linear function. This guy's derivative is 1. We proved that the derivative of x squared was 2x. Superstar homework problem. Prove to yourself that the derivative of x cubed is 3x squared. It's just a bunch of algebra. You're going to have to cube out x plus h. You know, not the most fun thing, but I think you guys can do that. So this is not going to be a proof, but I'm curious if you could see a pattern here. What's the derivative of x to the n? So pause the video, think about it. You might need to do something here to make this guy look kind of like these guys. Let's see if you can find a pattern. Right, hopefully you thought about that. I could think of this as 2x to the first. I could think of this as 1 times x to the 0. So it looks like these guys match. Right, this is x to the first. So it looks like it's nx to the n minus 1. This is known as the power rule. It's known as the power rule. Right, one other function that I want us to look at is f of x equals k. So k is just some constant, so k could be 3, k could be 7. Pause the video, please, see if you can come up with the derivative of that function. Okay, hopefully you pause the video. A couple ways you can think about this. If f of x equals k, then it's just a horizontal line. And the slope of that horizontal line is 0. So the derivative of a constant is 0. So that's one way you could have proven that. Another way that you could prove that is by the limit definition of the derivative. So let's do it that way. This one's a little bit interesting. So f prime of x is the limit as h goes to 0. F of x plus h minus f of x, so this is f of x over h. So if f of x equals k, what is f of x plus h? Pause the video and think about that. Right, hopefully you pause the video. Let me put my picture back up. This one's a little bit tricky for a lot of people to see. So here's x. Well, x plus h is over here somewhere. So if f of x is k, I guess f of x plus h is also k. This is the function. You put in whatever you want. K is going to be spit out. It's a very stubborn function. Okay, so this guy is a k here. And we get 0 over some non-zero number, which is 0. And we get 0. All right, so in this lecture, what we did is we abstracted things a little bit further. Now, instead of talking about the derivative at a single point, we have the tools to be able to talk about the derivative as being a function in its own right. And we also saw that by understanding the sign of the derivative function, it will tell us exactly whether the original function is increasing or decreasing. Hope you enjoyed the lecture. Thanks for listening, and I will see you next time.